subtracting, just like terms. Multiplying radical expressions is really straightforward too, and we actually did some of that up above. All right, so multiplying radical expressions means what's outside of the square root symbol or the cube root symbol, we can multiply together, and what's underneath the radical symbol, we can multiply together. But if they're outside and inside, we can't multiply those together. We have to keep them separated. So for instance, 2 times the square root of 5 is going to remain as 2 times the square root of 5. Okay, we can't multiply the 2 and the 5. Whereas this one, we have the square root of 2 times the square root of 5. That's going to be the square root of 10. Okay, and then we can do that with more complicated things. Notice that this 2x here is on the outside, but then there's nothing on the outside of the other square root. So the 2x is going to remain the same, but we have the square root of 5 times the square root of 2x. So that's going to end up being times the square root of 10x. Notice then all three of these, once we did our multiplication, I then have to make sure to look at the square root to see if I can simplify it. The square root of 10 can't be simplified, and the square root of 5 can't be simplified, so that I know that those are going to stay the same. However, sometimes after I do my multiplication, I can simplify the square root symbol, and so I have to do that. So for instance, in this one, the 3x is the only stuff outside the square root, so it's going to be 3x. But then I have the square root of 2 times the square root of 32x squared. So that's going to end up being the square root of 64x squared, because 2 times 32 is 64. Now I can look at the stuff in the square root and say, yo, I can simplify that. That's going to be 3x. The square root of 64 times the square root of x squared. But then everybody knows that the square root of 64 is what? It's 8 times, and the square root of x squared is x. So now I can multiply that all together, because 8 times 3 is 24, and x times x is x squared. That's what that would ultimately simplify to. All right. So also with multiplication, just think of a square root as being a number. So that means I can even distribute that square root. So in this case, I'm going to take that square root of 5 and distribute to the stuff that's inside the parentheses. 4 times the square root of 5 is just going to remain as 4 times the square root of 5. Whereas when I multiply the square root of 5 times the negative square root of 20, I'm going to get minus the square root of 100. Looking at these square roots, the square root of 5 can't be simplified, but the square root of 100 can. So this is going to ultimately be 4 times the square root of 5 minus 10. Okay? And then it doesn't matter if it's a little bit more complicated too. You just go through the same process as if they were numbers. This is 4 times minus 5 times the square root of 2 minus the square root of 4. Once again, I can't simplify that square root of 2, but I can simplify the square root of 4. 4 minus 5 times the square root of 2 minus 2. Now I can see, oh, I can do 4 minus 2, which is 2. So this is ultimately 2 minus 5 times the square root of 2. All right. The same rules apply to cube roots as well. So if I have 2 times the cube root of 5, it's going to remain as 2 times the cube root of 5. I can't multiply that 2 and the 5 together because one is outside the cube root and one is inside it. Whereas this one is going to be the cube root of 2 times the cube root of 5 is going to be the cube root of 10. I cannot simplify that any, so it's going to remain like that. Same thing with this. Stuff that's outside the cube root is 2x. The stuff that's inside the cube root is going to be the cube root of 10x. Once again, I can't simplify anything in the cube root, so it's going to remain like that. Whereas this one, outside the cube root is 3x. Inside the cube root, it's going to be 2 times 32, which is 64, x to the third. Now we should be able to see that the cube root of 64 is something, and I can simplify the cube root of x to the third too. The cube root of 64 is going to be 4, and the cube root of x to the third is x. So this ultimately goes to 12x squared. Okay. Then, just like we did in the other ones, we have 4 times the cube root of 5 here minus the cube root of 5 times 75 is, what would that end up being? I did it over here, 375. Okay, so then I have 4 times the cube root of 5. I know I can simplify this to be the cube root of 125 times the cube root of 3. This ends up being 4 times the cube root of 5 minus 5 times the cube root of 3. These have different cube roots, so I can't combine them. And then the last one, I have 4 minus 5 times the cube root of 2 minus the cube root of 8. Oh, I can see that that's going to end up being something because 4 minus the cube root of 2, can't simplify that, but I can simplify that to 2. So this is ultimately going to be 2 minus 5 times the cube root of 2. So remember, when you're adding and subtracting radicals, you can add and subtract, or you can, it's like combining like terms as long as they have the same stuff under the square root or the cube root. And then for multiplying, we can multiply the stuff that's outside the radical together, and we can multiply the stuff that's under the radical together, and that's how we can end up with our final simplified version. So that's all you need. Bye.